Hello, this is Brian Kinghorn, and I'm going to tell you today about how to set up your MateCell job to handle grouping using the parameter file InpGroups.txt. We've already talked about preparing your main data file in MateCell.ini and a file required when you're not grouping called InpOneGroup.txt, and it's worth having looked at this one before the current video because I go into some detail on components which I'll just touch on lightly in this video. So we're going to talk about standard operations today and advanced operations in a later video. Grouping is where you make decisions on which animal belongs to which group, and then you set constraints on patterns of mate allocation across groups and other constraints within groups. There are other ways of handling division of animals, which we've already talked about in the previous video, and I can point out these three different components can be simultaneously implemented as required for your breeding program. And this is the InpGroup.txt that is distributed with the MateCell software. I'll go into details about the components of it in later slides, but first I just want to look at the bottom here at the mating permission matrix, which is basically saying that you can mate males from group 1 with females from group 1 and males from group 2 with females from group 2, but not the cross matings between them. That's what's declared in that little matrix. Let's look at the data file that we'll use for this. It's MateCell Classic Demo, but I've made the IDs sequential, and then I've allocated mating group 1, 2, 1, 2, like an alternate plate drop at a conference, so that all the odd numbered individuals are from group 1 and all the even numbered individuals are from group 2. So let's make a run. I'll open the file, which is actually distributed with MateCell software, at this stage at least. And because it wasn't in the initialization file to initiate it as true for grouping, I'll just put in T, which is enough there to do that, and make the run. And here it's coming to conversions, so I'll click Print Matings and look at the mate selections. And we can see when we look at the two groups for sire and dam that it's either 2 with 2 or 1 with 1. And that indeed all the even numbered sires are mated to even numbered dams and vice versa. So let's just go and make a little change just to try this out. If I go down to the mating permission matrix in that file and set that to allowing group 2 males to be mated with both 1 and 2 females, save that and rerun. And that file is read after the run button is clicked, so I didn't need to reopen the file as I would if I'd made a change in matecell.ini. So we don't need to wait to the end. I'll click print mating straight away. And you can see that group 2 males can be mated with group 1 or 2 females, but any group 1 individuals are only mated to group 1 individuals. So that's a very simple demonstration of how grouping is operating. Now we'll look at something a bit more useful. So this is a more complete example, and I'll show you how I made the data file for this in case you want to reproduce it. It's MateCell Classic Demo, and I've just allocated 1, 2, 3, 4, 1, 2, 3, 4 all the way down the column of mating groups, and then I've added a 1 in the front of that for sex 1, which is male, and a 2 for female, so that if I recomplete what I did, there are the 1s, and further down if I go to any females, you'll see there are groups 21, 22, 23, 24. Now these are subgroups, and we have to do this because in many cases people want to amalgamate groups and use them together as a group for the current job in MateCell. So 3 groups there are going to be in MateCell groups, and here they are, 3 lines following that first line declaring 3 groups, and the subgroups are 11, 12, and 13 and 14 are the one group. And for 4 I've kept them separate. There are 4 female groups, and the subgroups are just allocated 1-to-1 basis. Now this next line here has a 1 in it, meaning that this line is going to show numbers of matings rather than selection proportions. So we're wanting to go for 20, 20, 20 and 100 matings in the 4 female groups. Now you'll see later that the number of females in group 4 is only 27, and yet we want 100 matings, so immediately we can see there's reproductive technology going on here. This 1 here is a switch to say we want to adhere to those numbers strictly, 20, 20, 20 and 100. If we had a 0 in here, then these female groups would compete with each other for matings, and you would tend to get a better technical result, although it may not be of practical value to you. However, this is the sort of situation where it's very good to release the constraints by putting a 0 in here, for example, and seeing what you might be missing out on by avoiding the dogmatism of having a certain constraint that you want to apply, even though it's of practical value. Here, the male groups 1 and 2 could be backup sires. So in actual fact, male group 3 I've conceived of as artificial insemination and not suitable for backup. And the female group number 4, we want to have more backups reported to be more secure for that reproductive technology operation. I'm going to talk about male and female pre-selection in the next slide. And then we'll also talk about the constraints on usage. These things follow from the previous video quite closely, so I'll just touch on them. But we can note that the max use and min use for females in group 4 is 10, which means that females, if they are used, have got to be used exactly 10 times. The male natural mating vector we'll talk about in the next video, and here's the mating permission matrix which I have applied for this example, and I then had to think what scenario this would fit with, and you'll see that coming up in a couple of slides. So pre-selection is very similar to the previous video, except now we've got multiple groups, and so in this case with male pre-selection we've got a proportion for group 2 of 0.8 and a number of 12. So this is 0.8 of the value before pre-selection, which was 10, so 0.8 of 10 is 8, and we're saying we want exactly 12 here. And just on the side we can see there are those 27 females which have got 270 matings available through reproductive technologies, and the number of matings we want to actually achieve in that case is 100. And this is a later patch into the video to describe the improved method we have of handling usage constraints, and it's probably best to show you by example. Here we have the male max use numbers, and for our AI group we're allowing 200 matings per male. But let's say, for example, that some males we do not have as much semen as that, and the males themselves are dead. If we put a -1 there, it's a switch to tell MateCell to read the max use numbers for individuals in that group, group 3, read them from the data file, and then you have a separate max use potentially for each male in that group. And that's an advantage of using this way, is we can mix and match global setting. Here we are 30 for everything in group 2 versus individual setting, and of course we could have individual setting of max use values in group 1 by telling MateCell to read these max use values from group 1. This also applies to abs min use and min use. So for example, if we do have semen from some bulls in the AI group that we definitely want to use, then we can put a -1 there. That means that MateCell will go to the abs min use column in your data file and read the absolute minimum use of these individuals in group 3. Now, if you use a -1 here and you do not have abs min use or min use column, then the value that will be taken by MateCell is 0. So everything I've told you is on this slide. You can look at it again. And just to note that the old way of handling these constraints is still supported, and see the manual for that. So here is the scenario that I've dreamt up. The female groups are in red and the male groups are in blue, and this is the permission matrix. So male group 1 can mate with 21 and 22 female groups, and the reason for that is that they're all located closely to each other here in Texas, and we're going to use group 11 males as bulls. Similarly, over in Florida, 23 and 24, these female groups are going to be mated by bulls from group 12. And we don't want to use group 12 bulls in Texas and vice versa, so that's why we have 0s here, and that's largely down to transport costs. And then groups 13 and 14 I've conceived of as semen coming out of AI stations in Texas and Georgia, and these can be used across all the female groups with no constraint, and therefore we have mating permission of 1 across each of those. So let's make a run. I've opened the file. Alright, and while that was happening I switched my lights on, and if I click matings, now this is the actual mating. It's useful to go to show sire use, and I'll sort on group, and if I expand this out somewhat, we can now see that our grouping permissions have been adhered to. The group 11 male is used only over group 1 and 2 females, and group 12 males are only used over group 3 and 4 females, and group 13 and 14, which are in fact one group as far as this run is concerned, are used across those different female groups, all of them. We'll just see more males involved if we go for 50 degrees, because we're looking for more genetic diversity. That'll do. And we can see that those constraints are met quite nicely all the way. This result may be satisfying to you, but there are a number of reasons it might not be. One is that we are using these bools across different farms, and if we're going to be doing natural mating, then a bool can't be used in two different places at the same time. So London, I didn't know we had a London in there. Ideally we'd use London in group 1 or group 2 females alone, because then he would be used in one farm alone. So we'll look at fixing that in the next video. There are a couple of other components as well. One is we can go and look at InpGroups.txt, and here we can see the pattern of usage across groups, and we may not be satisfied with this pattern, so we want to control that, and that is something else we'll look at in the next video. And finally, we may also want to have an even spread or a more even spread of use of males across different groups, and that's a third thing we'll look at in the next video. Right, and before I leave, there's just one thing I'd like to point out, and that is if we make a mistake in the construction of this file, for example, if I take that group off there and say that we've got two groups and they are 13 and blank, then an error message will come. Got two values but expected 3 in this line of InpGroups.txt. And this has been very useful because we used to get quite a lot of files coming to us asking where's the mistake in my grouping file. Now all those errors are trapped, and hopefully you should find that you can construct this file and MateCell will help you to do it. So that's been a video on standard operations, and I've pointed to a few things that we'll do in the next video in advanced operations. So thank you for listening.